Next up in this power session is Nick Stamatillo, who will present on innovations and food waste. Nick is an Australian entrepreneur and founder of Whole, a food tech company based in Australia. With a background in engineering, Nick is combining technological innovation with sustainable practices to help shape the food industry. Please welcome Nick.
Thanks. So I wanted to tell you a little bit about the whole journey today, and it won't be the whole story, obviously, in 5 minutes. But our journey started about 5 years ago, really, and it was triggered largely by an appreciation for the amount of waste that exists out there, particularly in the food industry. You've probably heard some of these statistics before, but a third of the food produced in the world is never consumed. And so looking at that, it's clear to see that the food industry is broken. And if you look back on food production for, say, the last 200 years, you can map it out. You can see why. You have ingredient manufacturers that split out these raw ingredients into these little components only to pass them on to a food manufacturer who recombines them all together in a recipe. So it doesn't make much sense, and on top of that, there's a huge amount of waste that goes into that process. So at the beginning of our journey, we really started with two goals. One was to enhance nutrition. So how can we get the most nutrition out of our food to make people healthy, really? And the second part of that was to reduce waste. And so looking into the market, we realized that we couldn't do that just by coming up with new recipes. That wouldn't be a solution. So what we've done is to go back to the drawing board and to develop a new processing technology. So we really had to reinvent the way that we're thinking about food processing. And so that's what we spent the better part of the last 5 years doing. And we've developed something that we call WINX. So it's a crude acronym for Whole Ingredient Nutrient Extraction. But what it is, it's a novel food processing technique where we use massive amounts of pressure. We apply this massive squeezing force onto an ingredient and remove it very rapidly. And to simplify it breaks it down into very, very small particle sizes, so 5 to 10 microns. So it's so small that it can't even be detected in the human mouth anymore. So why is that important, and why did we do that? Well, coming back to our goals, when you make something really small like that, you make it more bioavailable. So you increase the ability of the body to uptake nutrition. And then coming back to our second goal is that you can take a lot of what is now considered waste and break it down into such small particles that they won't even know it's there. So if you're looking at things like fiber, which are taken out of a lot of processing, we can get it so small that we could put it in a beverage and you wouldn't even know it's there. So it's got massive opportunities to reduce waste, increase nutrition, and there's a lot of talk about protein, but the better part of the first world is more fiber deficient than protein deficient. So to put it in context for you, I'll give you some examples. So one of the major projects that we're working on commercially is in oats and oat milk, and I'm sure most of you have tried oat milk. When they make oat milk, they steep it, they do an enzymatic treatment, and really that's just to convert the starch into sugars. But after that, they're decanting out all the fiber from the product. And the reason for that is that if they didn't, it would all sediment to the bottom and it wouldn't look nice. With our process, we don't have to do that. So we can break down the whole of the oat to such small particles that you don't even know it's there. So we are able to, from a food manufacturer's point of view, increase their yields by retaining the whole of the oat. But that has a lot of other benefits too. The fiber in the oat is the part that reduces cholesterol and has all these health benefits too. Under such high pressures, we can also gel the beta-glucans in the oats, which means that you don't have to add seed oils or vegetable oils to the product. So yeah, it's a cheaper product to make, but it's also a much cleaner label product. So that's one example. The other one that I'll give you is around coffee. So we're working on two ends of the spectrum. One is on the spent coffee grounds that exist in such enormous quantities around the world. We're doing work with groups like JDE, who owns Moccona and Harris, and they have thousands of tons of this stuff. So taking that waste product, converting it back into a coffee concentrate that can be used as a flavoring or as a coloring. But the other parallel project is taking a different approach and saying, well, why don't we process fresh coffee instead and then never have the waste at all? And the way that we're able to achieve that is breaking it down into such tiny particles that you can drink the whole of the coffee bean and then you never have the spent coffee grounds. So that's two of the examples that are well advanced commercially, but we're also doing projects in fruit and vegetable, wine. We're doing a lot of animal trials on potato peel and how we can turn that into an enhanced animal feed. We're working with some of the biggest companies in the world, Ferrero, Nestle, Simplot. But we're very committed to working here in Australia and working with some of the great producers. So if you're out in the main hall, please feel free to come by and have a chat to us. Thanks.